Alright, so here we have problem 8, solving trig equations. So we want to solve over the interval 0 to 2 pi. So we have cosine 2x minus cosine x minus 1 equals 0. Alright, so, well, you notice both of them are cosine, but the problem we have is the angle here is x, and here the angle is 2x. Okay, so we've got to fix it. Well, remember, we have a double angle identity, and the double angle identity says that cosine 2x can be written as 2 cosine squared x minus 1. Okay, so I rewrote cosine 2x as 2 cosine squared x minus 1. That's one of your double angle identities. And then I'll write the rest of the problem down: minus cosine x minus 1 equals 0. And so that's going to be 2 cosine squared x minus cosine x minus 2 equals 0. Alright, so, well, we notice here this one doesn't factor, so we'll have to use quadratic formula. So I get cosine x equals, and so that's going to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And so that's cosine x equals 1 plus or minus the square root. And so let's see, that's going to be, what is that, 17? The square root of 17 over 4. So that would be negative 8, 16 plus 1 would be 17. Alright, so I get cosine x equals, so I'll have to punch each of these into my calculator. We'll do 1 plus the square root of 17 divided by 4, and that's going to be 1 point, and I'm going to round I'll round to 3 decimals, or cosine x equals 1 minus the square root of 17 divided by 4, and that is negative 0.781. Alright, so now when we look at this, this one, cosine x equals 1.281. Well, if you remember, whenever you take the sine or cosine, either one, sine or cosine, if you take the sine or cosine of an angle, you will never get a solution greater than 1. So this right here can't happen. So this one we know will not be a solution because this value here is larger than 1. Okay, just remember that this value here has to be between negative 1 and 1. If it's out here, if it's less than negative 1 or greater than 1, it can't happen. So the only one we have to work with is this one. Alright, so I'm going to erase all this and rewrite this up here at the top to give us some room. Alright, so I'm back. Alright, so now we've got cosine x equals negative 0.781. So that tells me for cosine that since it's negative, my solutions are in the second and third quadrant. But remember, we need to find our reference angle, okay, our reference angle, so we can use it to find the second and third quadrant angle. Well, remember to find the reference angle if you've watched my other videos, and I would recommend you do. So this is going to be cosine, and I need to find the reference angle, so I'm going to put R here. And remember, that changes to positive 0.781. So now my reference angle, I'm going to take the inverse cosine of 0.781, And I would recommend when you're working them, don't round this number. I'm just doing it for the video, so it'll be a little bit, so it won't take as much time. So I get 0.675 radians. Now remember, this is an angle measure. Okay, this is an angle measure. This is radians. It's not in degrees, it's in radians. So make sure your calculator's in radians. Alright, so let's look at this. I've got my second quadrant angle I need to find. So here, my second quadrant angle, well, here's my reference angle, 0.675. So x would be pi minus that angle, pi minus 0.675. So pi minus 0.675 is 2.467. So one solution, x is 2.467, and that's radians, remember that. Alright, so the next one, cosine is negative in the third quadrant. So I get my reference angle, 0.675, and so x is going to be the 180 plus the reference angle. So that's pi plus my reference angle. So pi plus 0.675 is 3.817. So that would be 3.817. And there's my answer. So remember, it was cosine equals negative. So that tells me second and third quadrant. But I need to change this to positive because I need to find my reference angle. Remember, your reference angle is in the first quadrant. So once we find our reference angle, which is this, we use it to find the second and third quadrant solutions. Alright, so hope this helped. Don't forget to like and subscribe. Check out my other videos. Alright, thanks.